Hi, everyone. This is Alex Yanushevsky, Director of AI and MT Deployments at Smartling. My talk is entitled A Look Under the Hood, AI, MT, MTPE, and Human Translation. Let's take a look at what we're going to be talking about. We're going to start out with when to MT. That's going to be our first topic. Then we'll talk a little bit about the history of machine translation. Then we're going to get into a little bit of technical stuff. So how to train an MT engine and what happens under the hood. Then we're going to talk about how we evaluate this engine. Is it good enough to put into production? And if so, why? I'm going to focus a little bit on tools that we have that actually enable us to train a machine translation engine successfully to produce reliable data. And some of these tools are also used in production for a better quality translation experience and for LQA. And it's basically part of our dynamic data management factory. I'm also going to talk about some really, really cool AI things that we're doing related to adaptive translation memory, which is basically fixing fuzzy matches. I'm going to spend a little bit of time talking about fixing machine translation output using LLMs like ChatGPT, GPT-3, GPT-4, because that's obviously a very hot topic, and conclude with the idea that you'll also see in some other presentations, and that's the idea of language AI and having AI enabled in every single step of the workflow as part of an overall content lifecycle workflow. So let's talk about first when to MT, right? We'd probably flip the question on its head and say, rather than saying when to machine translate, we would say when you should not machine translate. And what you can see here, I'm not going to read through all of these bullets, but basically you'll see that human translation really is reserved for content that has very, very high touch marketing or has a very, very high emotional engagement. Other than that content, you'll see that actually, and I'll prove this to you, that machine translation, especially when it's trained, is good enough, it's suitable enough, it's actionable enough that it can be used for a plethora of other use cases, be it informational machine translation for things like support tickets, forums, customer reviews, user-generated content, or for things that we use for online documentation, right? So things, for example, like websites, like low touch marketing for websites, some marketing materials, some blogs, some product manuals, right? So essentially the idea is that machine translation is imminently usable for the vast majority of content that a client has. So before we talk about how we train a machine translation, how we evaluate it, let's kind of take a step back about 50, 60 years and very quickly talk about the history of machine translation and how we got to now. The reason for this is I'll take you through these last 50, 60 years very, very quickly. And what's nice about it is you'll get an appreciation of how we got to where we are right now and why machine translation really is so good, right? So basically, machine translation started out, at least in the US, it was government funded, and there were experiments during the Cold War where basically we used rules-based machine translation, right? And the idea of that is, if you think back to your grammar days, we have a sentence, we make a grammar tree, we say, hey, this is a subject, this is an object, this is a verb, right? And you would do that on both sides. You would do that both for your source and the target, the language that you're translating into. Then we began to get a little bit more sophisticated and began to kind of move towards a little bit toward mathematics. So we'd look at things like, we'd give the machine an example and say, hey, if you know this example, you could probably extrapolate and give me something similar and change it a little bit. Then we began to see, and this is where actually we saw the advent of Google Translate, 2006, 2007, statistical machine translation. Basically, just really by and large, initially, it was pure math. Then we began to try to infuse it, because language is not pure math. We tried to begin to infuse it with some sort of logic where it would be math, but we'd also take into account reordering, phrases, syntax. Fast forward to 2016, so a mere 6-7 years ago, and we see Google Translate with its neural machine translation, right? This is the technology that we see in images, for example. Microsoft followed suit, right? And this was around for pretty much up until 2019, 2020. And then we see the latest iteration, which is these super transformers, these large language models. And of course, probably most of you have heard of, because of social media, how popular Chat GPT is, right? GPT-4, Google is coming out with Bard. You hear about DALL-E, for example, right? So we begin to have these huge models that are based on neural networks with billions and billions of parameters. And that's why we can do what we can right now in such an efficient way and with so much quality. So let me kind of quickly take you through examples of how we got there, right? So as I said, rules-based, very simple. We have a sentence, we parse the sentence, we say, okay, a girl eats an apple. Well, all right, girl's a noun, eats is a verb, right? In the present tense, apple is also a noun. We do the same thing in German, and that's how we get to our translation, right? Now, the problem with this is you need to write an enormous amount of rules when you're translating from one language to another, right? You need to write rules for both languages, right? Ultimately, what we're trying to get to is, this is called the Vacqua triangle. We're basically trying to get to this point here, which is called an interlingua, which is basically a representation that captures all languages. So kind of letting the proverbial cat out of the box, we're going to see this a couple slides from now when we talk about neural machine translation engines. At this moment, we don't have it yet because we're just dealing with rules. Right? Then the next iteration was example-based machine translation, right? We'd basically say, look, I have this sentence, I have the translation, here's my new sentence coming in. Well, look, I've got most of it, right? So all I need to do is replace theater with the translation for cinema, and there we go, I'm done, right? The problem is you're still going to have lots of exceptions. You may not have enough information to actually deduce what it is that you need to translate, right? So this wasn't used that much. We began to see forays into statistical machine translation, right? This is where things get interesting. So statistical machine translation consists of three tasks: a translation model, a language model, and a reordering model. So a translation model is, hey, I need to translate the word bank. I look at all of the translations that I have. I have bank as the financial institution, banco, almost 15,000 times. I have bank translated as orilla, right? A riverbank where I go fishing, I have a picnic. Half of that time, the probability is higher that you're looking for a financial institution where you deposit checks, right? So that's probably most likely what the engine will give you as the output. We do the same thing with a language model. We look at how we express ourselves in a language, right? And again, we look at probabilities. So you might say, more often than not, I say that I live in a house, a condo, an apartment. Most people are not going to live in a yurt, and most people are not going to live in a houseboat, right? So in most cases, again, this is the higher probability. And then finally, depending on the language, we do some reordering and we have our translation, right? So this is a technology that was around for about 15, 20 years. And then we began to see the advent of neural networks, right? So this is where we are right now. The idea of neural networks is you basically take words. These words are encoded to form a list of vectors. Basically, think of a bunch of different features that are encoded as numbers. And then we decode all of these numbers, processing them word by word. Now, the latest technology is transformer models, and that's what GPT is, general pre-trained transformers. And the idea here is, as we go along in the sentence, we actually we know what the context is of the word and the previous words and how they relate to each other, and we haven't lost that. The metaphor that I'd like to use is to try to think of neural networks and how they kind of work. They're supposed to approximate working the way your brain does, right? That's kind of hard for us to understand. I try to use this metaphor. If I asked you what this was, most of you within a matter of a second, if even that, would say, hey, this is a leash or this is a dog leash, right? So if you said leash and I said, well, what do you use this for? You'd say, well, you use it to walk a dog, right? If you kind of unpacked what your brain did, you probably said, okay, this is a leash. A leash could be used to walk some sort of an animal, right? It's probably not going to be a bird. It's not going to be a fish. You can't really walk those. It's got to be a domesticated animal, right? You're not going to walk a hippopotamus or rhinoceros. They're not going to be particularly happy about that, right? Probably won't be a cat. A cat's going to scratch you, and cats generally don't go for a walk on a leash. Probably not going to be a ferret, right? Because that's not that likely. And most likely it's a dog, right? I mean, it's kind of an anecdotal example, but the point is, all of these kind of contexts and hyperparameters, that's what's being encoded here. And that's why we can get such a good translation, right? So this is the state of the art right now. And then we go to large language models, right? And here, these neural networks that had hundreds and hundreds of thousands of parameters, now we're talking about billions, right? 175 billion for GPT-3, right? So these are neural networks that have been trained on large quantities of unlabeled text using self-supervised learning, right? We basically have very, very high-powered machines that'll crunch through examples, consider all of these parameters, and give us the correct output the vast majority of the time, right? So we see that they're very, very promising for machine translation. Some languages are better than others, right? But really the question here that we're still researching, not only us, but research themselves is, well, can we take these large language models like a chat GPT, like a GPT-4, can we give it customer data and fine tune it so it gives even more relevant output, right? And we'll kind of come back to this at the end of our presentation again. So this kind of brings us to the question of, well, if we're going to train a machine translation engine, how are we going to do it? Why are we doing it? What are we trying to accomplish, right? So in essence, generic machine translation engines, if you think of your Microsoft Bing translator, if you think of your Google Translate, they're very good for a specific task, which is, hey, what time does the restaurant close? Is this museum open today? How do I get from point A to point B? But they're not going to consider your client-specific style or your domain-specific terminology, right? They're not going to know that, for example, in the legal arena, when you're talking about briefs, right, you're not talking about close, right? So the idea here is we want to give this machine and the algorithms that it's using enough reliable bilingual client data so it can learn to generalize. It can learn your terminology and your style. But at the same time, we don't want to degrade the general engine, right? And that's what we see represented here pictorially. So think of Google Translate that has lots and lots of data from English into Spanish. And what we're doing is we're putting our data, our client data, for domain adaptation, right? We're basically giving more weight to that data, right? And that's the idea of training an engine, right? So a few things that kind of happen behind the scenes. There are tools that we use. First and foremost, if you notice, I talked about reliable bilingual data, right? Not just, hey, let's chuck things in there and pray and hope that it works out. What we do is we actually look at your translation memory files, glossaries, find inconsistencies in them. And here's the part that's really cool. For a lot of tasks, we're actually able to do some self-healing and correct the things that are incorrect, right? We also convert a glossary to a format that is specific for machine translation and get rid of some noise, right? Ultimately, we're cleaning translation memory files where we're removing incorrect or unreliable data from the files, right? Then we split these files into 3 buckets. And the buckets are, there's a train set, that's the basically 95% of your data. This is what the engine learns to generalize, right? This is how they learn your data, your style, your terminology, right? Then there is a bucket called the tune or dev bucket, and that's where the engine selects parameters and fine tunes them based on the set. And lastly, and this is how we evaluate our engine, there's a test set. A test set is basically data for which we know the answer, a human being translated it, but it's called held out data because we don't give that data to the engine. And that's how we ultimately see, is this engine as good as the human translation, right? The closer it is, the better that engine is. Then we give it a thumbs up and say, great, let's put it into production, right? So we'll kind of go back to this test set and how do we score an engine, right? So again, when we're doing empty engine training, right? Some of the other things, I spoke about these inconsistencies, right? So we can look at all sorts of mismatches there are between the source and the target, and we can also self-heal, right? And we have different priorities for what things are more important, what things are less important. But the thing that's really, really cool here is that using some AI tools, we can actually heal a lot of these issues. And then lastly, I spoke about the glossary, right? So a lot of times, a glossary may not be put together by a terminologist, right? And there are things that a non-terminologist might do that's really not necessarily good for an empty engine, right? So things like putting plurals in, right? Things like putting in very, very long phrases. So we have tools that actually allow us to find these items and actually, again, self-heal and take them out of the glossary so we have more reliable data. So once we're done training the engine, that kind of begs the question of, okay, well, how do you know this engine is good, right? And basically, there's two types of scoring that we do. There's textual scoring and semantic scoring. By textual scoring, this is pure mathematics. It doesn't take meaning into account, right? Whereas semantic scoring considers meaning. By textual scoring, some of you may have heard of things like BLEU, of post-edit distance. And really the idea here is I have my reference, right? I have my human translation. I have my translation from the MT engine, and I see how close they are. The closer they are, the more I match the human translation, the greater chance I can say, green light, let's put this into production. However, there are times when this post-edit distance, this automatic textual scoring doesn't work. And I've given you a couple of examples here, right? Imagine that the only difference between this sentence and this sentence is the defendant is guilty, the defendant is not guilty, right? It's only 3 letters and 1 word. So if somebody misses this, this is an amazingly, amazingly important thing that they missed that completely changes the meaning. And textual scoring doesn't capture this, right? The same thing here. There's a big difference if I have a car and I'm pouring gas into it or I'm putting oil into it, right? If I'm putting gas into the tank that's supposed to have motor oil or vice versa, I'm basically going to ruin the car, right? If I don't notice this, again, this is only 1 word and 3 characters. So the way we deal with this problem is this idea called semantic scoring. And semantic scoring is very cool. And this is the same thing that when we talked about our transformer models, right? The way we do this is basically we have words that are turned into numbers, right? With a bunch of different parameters. But for our purposes, because we as human beings can't visualize 100, 1,000 parameters, we reduce them to a 2D space, right? And basically what you see here is words that are close to each other, walk, run, jog, right, are plotted close together, and jump and bounce are plotted close together, right? But because jump and bounce are not related to walk, run, or jog, they're further apart, right? We can do the same thing with verbs. We could do the same thing with gender, right? And we could do it on a sentence level, right? So you could see that the 2 sentences here, the red and the blue sentence, they're more closely related. We've got a lion and a tiger, and we've got a jungle in the forest. The 3rd sentence, not even close, right? So this angle here, right, where this is plotted is called cosine similarity. And the smaller that angle is, the more related the 2 words or the 2 sentences are, right? Now, what this allows us to do is actually do this on the basis of different languages, right? So you could see these 2 translations in German and Japanese are very, very close to the English, right? And that's why they're a correct translation of the English. This is not even close, right? And it's in a completely different space, right? Now so what we're doing is we're basically evaluating an engine both from a pure mathematical textual way and a semantic way. The last thing that we do, which is pretty cool, is that we also look for glossary coverage. So if we know what our source should be and our target translation, we could actually run a tool that'll tell us when we see the source, how often do we see this translation and is it correct, right? So all of these things go together for us to really have a full picture and say, yes, we can put this engine in production, right? So when we put an engine into production, what we basically do is we go back to the client and say, look, we've hooked up the engine. We've configured it in the Smartling platform with your correct model ID or category. We've given you evidence that this trained engine is better, right? And here's another piece of evidence, right? This is also one of the deliverables. Here we can see here I have 0 edits, right? For about 400 sentences. This is complete human parity. It means that the machine translation engine is so good that it's no different what a human being did. This bucket here is near human parity, right? And basically for us, we say anything that's less than 0.5 edit distance and lower, we can use and it's actionable. So you can see here that the vast majority of the sentences, a linguist would find them actionable and be able to work with them, right? And that's why we're able to give committed discounts for post-editing when using our Smartling language services. So I wanted to talk, I started alluding to them a little bit. I wanted to talk about some of the tools that we have that have AI underpinnings. So I gave you examples of TMX LQA and how we can correct inconsistencies, examples of how we do a cleanup on a translation memory files, how we split it to ultimately train a machine translation engine. I just showed you this example of glossary coverage and auto scoring. The other two things that we've done, and these are very, very like state of the art, very, very neat things, is this idea called content drift analysis and edit nature analysis. So what this does is content drift analysis, if you remember our idea about plotting sentences, right? We can basically say, look, we've trained an engine on all of the sentences that are in red. You've given us new content, and that new content is represented by the sentences in blue. If you draw a diagonal line here, you can see that by and large, they significantly differ from each other, right? What that's telling us before we even begin working is the engine was trained for one task, but now we're giving it different content, so it's not going to perform as well, right? The reason that's important is we can basically say, hey, let's stop the process. Let's make sure that we add this into the training so you'll be successful, right? And we can do this before, the train leaves the station, before we start doing production work. The other thing that's neat is this idea of edit nature. So we can actually see when a linguist or when a reviewer is editing something, what is it that they're doing? Are they making preferential changes? Are they making no changes at all? Right? Are they making changes that's just punctuation? So it gives us great visibility into what they're thinking, how they're thinking, and are they making changes that are maybe just preferential and really don't add that much value? Right? So that's a very important point. So I wanted to talk about some state-of-the-art things that we're working on. One is adaptive translation memory using AI. So here if you remember, we spoke about these things like guilty, not guilty, oil and gas, right? The problem is if someone doesn't correct it or it remains mistranslated, this may lead to brand erosion. So what we can do is we can take these high fuzzy matches from the translation memory, and we have proprietary in-house neural machine translation engines where we can do some fine tuning, basically choose the 5 best translations and propagate the best translation out of those 5 to ultimately repair the translation memory and give the correct translation, which reduces the likelihood that it'll be uncorrected or mistranslated and makes the linguist work more quickly, right? The other thing, we started talking about LLMs, large language models, and GPT-3, ChatGPT, GPT-4. So one of the use cases that we have is how do we correct machine translation output by using targeted prompts, right? Prompt engineering in these language models. So basically what we're trying to do is we get an output from machine translation. It may be less than optimal for some specific use cases, or we need to debias something that was in the machine translation engine. And we could do really, really important things like we could inject the glossary for correct terminology, but with the correct grammatical form. We could switch formality, right? So if a client says, I would like this to be formal because that's how I'm addressing my users, or conversely, I want this to be a bit more playful and informal, we can do that. We also can take a style guide and we can teach the large language model to use the style guide of the client, right? So for example, if you're Disney, you might say, I want a more colloquial, playful tone, whereas you might be a bank like TD Bank or Bank of America, and you might say, I would like a more proper formal tone, right? And we can take your style guide and using prompt engineering, teach the language models to do that. Right. And also we can do gender switching, debiasing. So this was a great example for a client we had where the governor of a state used to be male, became female. Now, machine translation engines, unfortunately, have a lot of historical bias where doctors are male, governors are male, senators are male, right? Nurses are female. That's actually, completely incorrect, right? And what this prompt engineering allows us to do is actually change that. And in this case, the governor of New York State was actually female, and we were able to correct that by using prompt engineering, right? So some of these things that I described here, this is basically patent pending technology for us. So I want to finish with this idea, and probably kind of saw this theme woven all the way through, and you'll probably see it in some of the other presentations as well. The idea of language AI in every single step of our workflow, right? So essentially, from the time that we analyze the customer content, we're using AI. And when we finish with the post-editing examples that I give you, we're using AI to produce the best target copy, right? And ultimately, what we believe is going to happen is translators who are already becoming post editors will have an even more exciting job, which is they'll become content engineers. They'll be interfacing more and more with these language models. And it's a very rewarding task to actually see a language model, basically program it in human language to give you the output that you want, right? So we see translators becoming more and more content engineers, and we see localizers becoming more global content partners. So thank you very much for your attention. And if you have any questions, please feel free to get in touch. And because there's no QA for these sessions, we'll answer these questions and respond back to you by email. Again, thank you so much.